In objective number 6, we're going to start graphing these rational functions. Now, just like all the other graphing we've done in this year, we're going to start off with the parent function. So the parent function is f of x equals 1 over x. Now remember, y is the same thing as f of x, so you could rewrite it y equals 1 over x if you want to. Now, let's think about some restricted values. Throughout the entire unit, we've been worried about getting 0 on the denominator. Well, this is pretty easy. X is a restricted value. X cannot equal 0. Because if it were, we'd have an undefined fraction. But we're going to do something we've never done before. And that is, we're going to put a restricted value on y also. Now, y equals 1 over x. The only way you can get 0 as an answer to a fraction problem is if you have a 0 on top. Well, we don't have a 0 on top, we have a 1. So the value of y will never be 0 in this equation. So y is also restricted and cannot equal 0. Now what that's done is that's set up our asymptotes. X equals 0 is a vertical line right here, and that's an asymptote. Y equals 0 is a horizontal line right here, and that's an asymptote. Now, let's start looking around where the points do exist in this graph. Let's plug in a value of x equals 1. Well, when x equals 1, y equals 1 over 1, which is also 1. Now, notice you can also call this a reciprocal equation. All we're doing is we're taking the reciprocal of x. So when x equals 2, y is 1 over 2, which is 1/2. Do it one more time. When x equals 3, y is 1/3. But it works the other way around also. What if x has a value of 1/2? Well, 1 over 1/2 is the reciprocal of 1/2, which is 2, and 1/3 would be 3. So what's happening with this graph? Let's graph the lattice point 1, 1. Over 1, up 1, over 1, up 1, it would be about right there. Now, as my x values get larger, my y values get smaller, but they never touch this asymptote. On the other hand, as my x values get smaller, as they get closer to 0, my y values get larger, and the graph that produces is a graph that looks like this, or something like that. Now, I could use negative values of x too. When x is -1, y is -1. When x is -2, y is -1/2. So the exact same thing happens down here. And the graph does this. So that's the parent graph of f of x equals 1 over x. Now let's look at some of the specifics on this graph, the x-intercept. Where do either of these two curves hit the x-axis? And the answer is they don't. The x-intercept does not exist. Same thing with the y-intercept. The graph never touches the y-axis. It comes really close down here and it comes really close up there, but it never touches. So there is no y-intercept either. So the y-intercept doesn't exist. Now, the vertical asymptote. The vertical asymptote was right here at x equals 0. The horizontal asymptote was right here at y equals 0. Now the domain. If you think of left to right, the graph uses all real numbers except the number that represents the asymptote. It makes a jump right there. So as far as the values of x are concerned, because that's what domain is, it goes from negative infinity all the way to the asymptote at 0, but remember it doesn't touch it, so I put 0 but with an open parenthesis, and then it jumps it, and then on the other side of the 0 it starts right up here and it goes to positive infinity. Now the range does the exact same thing, only think low to high. If the graph were continuous, it would go all the way from the bottom to the top, negative infinity to positive infinity, but it can't touch that line right there. So we have to do it in two parts. Negative infinity to 0, and then it jumps, and then it picks it up again on the other side of 0, and then goes to positive infinity. And then the last set of questions that they ask is increasing and decreasing. Where is this graph increasing? Well, it's never increasing. This is a decreasing graph. If you go left to right, it's always decreasing. And then it jumps the asymptote up here, and then it continues to decrease all the way through the rest of the graph. So it's actually the same as the domain. Negative infinity to 0, and then from 0 to positive infinity. Okay, now that we know what the parent function looks like, we're going to rely on the rules of shifting to do all the other graphs. We are no longer going to make a table of values. So if you see the equation like this, f of x equals 1 over x plus 3 plus 5, we're going to rely on what we know about shifting functions. Anything that's directly connected with the x, whether or not there are parentheses, in this case there aren't, is always the opposite. So this part is the opposite, and this part is the same, which means my translation or my shift is going to be 3 units to the left. So left 3 and up 5. Now what's actually being shifted? Well, if the asymptotes is the short answer. Remember the asymptotes on the parent function met at 0, 0. That's the place they crossed. Well, now they're going to be crossing at negative 3, positive 5, because that point of intersection is going to move 3 units to the left and 5 units up. So let's say that right there, 3 units to the left and 5 units up, is the place that they're going to meet. Well, if it started at 0, 0, then that means their meeting point is negative 3, positive 5. So that's where the asymptotes are going to meet. That's where we're going to start this. We are going to put in those asymptotes. We're going to put the vertical one right here. And we're going to put the horizontal one right here. Now that gives us the equation of those asymptotes. This vertical asymptote, remember, was moved 3 units to the left. So now that's x equals negative 3. And the horizontal asymptote was moved 5 units up. So that's y equals positive 5. So I can go ahead and answer these two questions right here. My vertical asymptote is x equals negative 3. And my horizontal asymptote is y equals positive 5. And I can just fill in the rest of the graph with, what I know the basic graph looks like. Since this is a 1 on top, my lattice point doesn't move. I just go 1 over 1 up from the intersecting point of the of the asymptotes. And as I go to the right, it gets closer and closer, but as I go to the left, it also gets closer and closer to the other one. So the graph looks like that up there. But it does the same thing down here. I'm going to go, over one to the left, down one down, and that's going to be the estimated point. As it goes further and further this way, it gets closer and closer, but as it goes the other way, it also gets closer and closer. So that's the graph of the other one. So that's what my graph looks like. Now, does it have an x-intercept? Well, sure it does. It's right here. Here's where this part of the graph crosses the x-axis. Now, this one never does. This part of the graph never touches the x-axis. So there's one x-intercept, and there it is right there. How do we find it? Just like we find all other x-intercepts. Set y equal to 0. Go back to the function, set the function equal to 0. 0 equals 1 over x plus 3 plus 5. Now the easiest way to solve this would be move the 5 to the other side, making it negative. Negative 5 equals 1 over x plus 3. Cross multiply, distribute that negative 5, and it'd be negative 5x minus 15. Watch the sign. And when you distribute the other way, remember there's a 1 under this negative 5, so it would be that 1 times that 1, which is simply 1. So negative 5x equals, add 15 to each side, 16, divide by negative 5, divide by negative 5, equals, positive divided by negative is negative, so negative 16/5, or that would be negative 3 1/5. So that's where that point is, right there, at negative 3 1/5, or negative 3.2, if you want it in decimal form. Now, what about the y-intercept? Where does this graph cross the y-axis? Well, it crosses the y-axis right there. So let's figure out what that point is by setting x equal to 0. So y equals 1 over 0 plus 3. All I did was I went back to the equation and I put a 0 in for the x, plus 5. So y equals 1/3 plus 5. So y equals 5 1/3. So we have the x-intercept and we have the y-intercept. Now we have a few more questions that need to get asked about this graph, or answered about this graph, and I moved my worksheet up so I want to be able to see the graph the entire time. If I were to move down to where these normally were on the page, we would lose the graph. I don't want to lose the graph because we need the graph to help answer these questions. The domain. The domain is all the values of x that are used by this graph. Well, remember, x equals negative 3 is really only the only restricted value of x. If I went left to right, it would be all reals, except I can't touch negative 3. So I have to do it in two parts. Negative infinity to negative 3, open parentheses, which means I can't touch it. And then on the other side of negative 3, go to positive infinity. Now I'm going to do the same thing with the range, which is all the values of y. But instead of thinking left to right, think low to high. It would be all reals, except I can't touch that positive 5. I have to jump over it. So as far as the range is concerned, it would also be negative infinity, but it would go up to the asymptote of 5. Can't touch it, so that's why the open parentheses. And then on the other side of the 5, go to positive infinity. Now, where is this graph increasing? It's never increasing. It's always a decreasing graph. This part is decreasing, and this part is also decreasing. So all we have to do is rename the domain again. Negative infinity to -3 and -3 to positive infinity. And now state the intervals of the graph where f is less than 0. Now you already have done the answer to this, but it's tricky. Remember that x-intercept right there, and its value was -3 1/5? Well, this graph is below the x-intercept, below the x-axis in this tiny little region right here. Otherwise, it's always above 0. So all we have to do is name this tiny little region. Well, this tiny little region begins at -3, I think it's 1/5, -3 1/5, not -3 1/2. -3 1/5, and then it ends at the asymptote of -3. For example 3, we're not going to do anything different except this is all written in function notation now, to where h of x is the composition of g of f of x, which simply means we're going to take the f of x function and we're going to enter it into the g of x function, and the only place it can get in is right there. So that makes the h of x function equal to -1 over, and then put x plus 4 down there. It's just substitution. X plus 4, and then -3. Now, we've got the shifting going on. The asymptotes are going to shift 4 units to the left because of the x plus 4. So 4 units to the left, and then 3 units down. So that means that the asymptotes are going to meet at the point -4, -3. And that's going to help us with the rest of the graph. So figure out where -4, -3 is. Okay. Right there. And that's where your vertical and horizontal asymptotes are going to meet. So I'm going to draw those vertical and horizontal asymptotes. Here's the vertical one. And here's the horizontal one. Now the equation of those asymptotes, the vertical one is x equals -4, and the horizontal one is y equals -3. Now, the only thing different about this graph from all of our others is look at that numerator of -1. That numerator of -1 right there. All it does is it changes the quadrants of the graph. I'm going to put a point right here, and it does that. And I'm going to put another point right here, and the graph does this. So that's the equation of the graph. This is what the graph looks like. Now, does it have an x-intercept? Sure it does. It's right there. So let's figure out what that x-intercept is, again, by setting y equal to 0. So go back to the h of x function, set it equal to 0. 0 equals -1 over x plus 4 minus 3. Now move this negative 3 to the other side, which would make it positive. 3 equals negative 1 over x plus 4. Do your cross multiplying and remember to distribute. 3x plus 12 equals negative 1. Swing the 12 to the other side by subtracting it, and we get 3x equals negative 13. Divide both sides by 3, and you get x equals negative 13 over 3, or negative 4 1/3. Okay, now let's move on to the y-intercept. Visually, the y-intercept happens right here. This is the location where our graph crosses the y-axis. So now we just have to figure out where is that. Let's figure that out by setting x equal to 0. Go back to the h of x function and just put 0 in for that value of x. So y equals negative 1 over 0 plus 4 minus 3. So y equals negative 1/4 minus 3, which equals negative 3 1/4. So that's my y-intercept. Now, let's move on to some of the other things we asked for. Vertical asymptotes, we've already got it. The vertical asymptote is x equals negative 4. The horizontal asymptote, we've already got it. It's y equals negative 3. The domain and range. Domain, think of all the values of x except for the negative 4. So it has to be split. The domain has to be split from negative infinity to negative 4, and then it jumps negative 4, and then on the other side of negative 4, it goes to positive infinity. Now the range does the exact same thing, except think low to high. The only value of y it can't touch is negative 3. So the range is going to be negative infinity to negative 3, and then negative 3 to positive infinity. Now, increasing. Where does this graph increase? Well, this is a forever increasing graph. If you look at this part right here, it's starting here, and it's going up, 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 and then it jumps to down here, and then it goes up, 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 up again. So, it's always increasing. So all we're going to do is we're going to rewrite the domain of the graph. Negative infinity to negative 4 and negative 4 to positive infinity. Now, where is it decreasing? Never. Now, where is this graph less than 0? Or another way of thinking about that is, where is this graph below the x-axis? Where does it have y values of 0? Well, here's one part. From negative infinity to that point right there. And remember, that point was the x-intercept, which was negative 4 1/3. So from negative infinity to negative 4 1/3, the graph is underneath the x-axis. But that isn't the only place the graph is underneath the x-axis. This entire part of the graph is below the x-axis. So, starting from the other side of this asymptote, from -4 to positive infinity, that part of the graph is underneath the x-axis, so it is less than 0. For this last problem, example 4, I'm going to put two different functions on the same graph. Let's graph f of x and g of x. Let's do f of x first. F of x equals 18 over x. So all we're doing is f of x right now, 18 over x. There's no shift at all, so therefore I know where my asymptotes are. My asymptotes are the x and the y-axis. So with green, I'm going to mark the asymptotes. Now, up until now, the numerator has always been 1, but this time it's 18. So what is that going to do? All it's going to do is push our lattice point out a little bit. The easiest x to discover would be what happens when x is 18. Okay? If you plug in 18 for x, 18 over 18 is 1. So that gives us the point 18, 1. So I'm going to come out here quite a lot, 18, and I'm going to go up 1, and I'm going to make that point. Now I know what this graph does. It stretches out to this asymptote, and it stretches down to that asymptote. So that's what I'm going to do. I'm going to stretch it up to that asymptote, and I'm going to stretch it down to that asymptote. Now I'm going to do the same thing, what if x were negative 18? Okay. If x were negative 18, 18 over negative 18 is negative 1. So my point would be negative 18, negative 1. And the graph would do the same thing. It would stretch down to this asymptote, and it would stretch up to that asymptote. So those are my two graphs of f of x. So this is f of x, and this is part of f of x right here. So the green curves are f of x. Now what about g of x equals 3? Well, that's a constant. G of x equals 3 is just a horizontal line at positive 3. So I'm going to put where I kind of think positive 3 is at. And I'm going to make a horizontal line. And I'm going to say that's g of x. So where do f of x and g of x meet each other? They meet each other in one place only, and that's right there. Now, algebraically, where is that place? Well, we're going to set the two functions equal to each other. F of x equals g of x. F of x is 18 over x. G of x is 3. So we just need to solve that. By cross multiplying, 3 times x is 3x. 3x equals 18. X equals 6. So what does that tell us? That intersecting point right there is where x equals 6. So the last part of the problem, explain the relationship of the algebraic solution to the graph. When x equals 6, y equals 3, the intersection of f of x and g of x is x equals 6, y equals 3, otherwise known as the ordered pair, 6, 3.